Good afternoon, everybody. My name is Ying, and I'm a software engineer. And this is Marc, our product manager. Today, we brought you 3 new ways to secure your application with Firebase Auth.
Hello, I.O. We're the second last session for the whole conference, so this is jam-packed. But first, I'm going to start with the story. Just by show of hands, who's worked at a really large conventional company before? Like big, slow-moving, like takes a while to get things done. A few of you, about half? Okay, cool. So I have 2. Hopefully this story resonates. If not, hopefully you'll come along for the ride. I want to introduce you to Bob, or Big Ol' Bank. Bob is about to turn 100 years old, and unfortunately, so is their infrastructure. They've got mainframes, they've got all sorts of stuff sitting in the back closets. It's really hard to get that stuff into the cloud and get modernized. And as I'm sure you've all seen, if you're a bank in today's day and age, it's kind of tough. You got agile competitors popping up left and right, people transferring money, people on the go, people with phones, all that sort of stuff. So I wanted to introduce you to Sue and Alice. Sue is an engineer at Big Ol' Bank, and Alice is the lead UX designer. And they have one mission. Their challenge is to save Bob. And so what they want to do is build an app that's integrated with all of Bob's legacy assets. They want an app that understands who you are, where you are, understand that you've got a busy social schedule, your calendar's full of concerts and all that sort of stuff. But you also need to be able to transfer money with friends and exchange finances and things like that. And so they went away long and hard, and Alice conceived Wulp. Wulp was an app that let you see people nearby, be able to transfer money with them, either with your Big Ol' Bank account or some other account that you might have, being able to integrate with back-end services and front-end services. But mock-ups are great, but actually making that tangible is hard work, especially when you're a 100-year-old company. And the stakes were so high. I'm sure if you read any tech on the web, you've probably seen these sort of headlines. And Sue and Alice weren't planning to make headlines for the wrong reasons, to be honest. So there was a lot of things they needed to do to build this Big Ol' Bank application. And at the core of it was keeping people secure. They need to be able to create accounts, manage life cycle of accounts, verify people are who they say they were. Also do things like, how do I personalize it? How do I make it feel real for end users and make them want to come back, want to continue using it? And then, importantly, when someone decided they didn't want to use the app anymore, how do I clear out all that data? How do I preserve their privacy? How do I do all the right things to make sure that I don't store data that might get me into trouble with regulators or whatever the case is? And most importantly, as I said, integration was critical. They can't just spin up this brand new app and throw away all the things they've spent 100 years investing in. So it had to connect to these mainframes and all these systems. So they figured out some things they needed to do. They needed to know who people were. They needed to know how to report to regulators, to auditors, to compliance and things like that. They needed to protect user data, protect bank account information, to protect all those sort of things. And not just from outside risk and hackers and things like that, but there's also insiders as well. Insider risk is a very, very real thing. And one way to do that, they thought, maybe we can reduce the amount of data that's stored for each user. So there were some must-haves. The app had to be secure. It's people's money. It had to be planet scale. It couldn't just be restricted to certain geos, or specific devices, whatever the case may be. It had to be flexible. They had to be able to use this app anywhere with the things that they had, with the people that were coming to it. It didn't matter who they were or where they were coming from. And finally, extensibility was super important. So,
that's obviously Big Ol' Bank need a solution. And that's exactly Firebase Auth are positioned to help. Let's see why that is. So from the very surface, Firebase Authentication provides multiple ways for the user to sign in to the awesome application that you have already built. Here it includes Google sign-in or Facebook sign-in. It can also have email password. And sometimes user may prefer some passwordless sign-in, for example, SMS-based sign-in method. But no matter how the user signs into your application, we always create a user account underneath and then issue a JSON Web Token so that your application can just pass that token and get users' account information, so that you can optimize their experience with your application. If we look a little bit under the hood, Firebase Authentication is actually built on top of a highly reliable storage system. And we provide a set of APIs for you to manage your users the way that you need. But we know too well that actually based on our own experience, that every application needs some must-haves, just as Marc just pointed out. You need to handle, for example, user forget their password, or user need to sign up, or user need to sign in with different identity providers, etc. So your client-side code can be easily become complicated and messy, and sometimes also error-prone. That's why we also provide client-side SDKs that can build into your application across iOS, Android, and web. We also have admin SDKs that can be run on your server side so that you can operate on the user's account. Besides that, building applications, sometimes we need to act very fast. It can be, for example, I want to get my application up on the market so that user can start using it. Or sometimes it can be, oh, actually, I just need a fast proof of concept. So that all require you to move fast. In this case, then you can leverage our existing built-in UIs so that you can get your application up and running. Now, I want to talk a little bit about the principles that Firebase Authentication is built upon. The first thing, obviously, for big old bank, they need security. The good news here is that Firebase Authentication is secure. So what do we mean by that? It actually have multiple layered security built in Firebase Authentication and delivered to you by default. So let's take a look at that. First layer of the security is the SDKs. All our SDKs, before they were delivered, made available to you and built into your application, we went through rigorous security review as well as third-party pen test to make sure that they're good to use. And when our SDK send request to Google, that communication is encrypted at transit. And when that request reached Google infrastructure, there are multiple layers of abuse detection and load balancing to defend your sign-in against a denial of service. And when that request actually reached Firebase Authentication server, the server side actually rely on Google infrastructure to make things happen. And the server-to-server side, server-to-server trust is never assumed. It always has to be explicitly expressed so that the information about your user is secure. And last, when the user account is created in our storage, all the data are encrypted at rest. So with that, you probably still have questions regarding the details of how the system work or how we do our daily operations. So to answer this question, we actually run SOC 1 and SOC 2 report periodically. Here, the SOC 2 report is actually hundreds of pages of reports regarding the security controls that the system have, with SOC 1 report has more detail about the internal users' handling of financial reporting. But this report, although it's very detailed, it doesn't actually say that the system is secure. To get to that, we actually compare these reports against some ISO standards. Here, the ISO 27001 is an information security standard. It details the controls that we have with regard to information management risk. And then with the shift from on-prem system to cloud, the ISO 27017 actually specifies more on the cloud providers. For example, what is the responsibility of you as a service consumer versus us as a service provider, and how the administrative operations are conducted, those kind of things. And then the ISO 27018 has more focus on user identifiable information. So it's more about privacy. So Firebase Authentication actually complied with all the three standards. The next principle here is about scalability. Given that Firebase Authentication is deployed on Google infrastructure, this is more like a given, actually. So your user might spread everywhere across the globe, and our service is actually accessible from anywhere. And also, when your application, you start rolling interesting features and users start to grow, or users engage more with your application, you don't need to worry about the scalability. So we handle that for you. Another additional benefit is that all the user account information are replicated across data centers. So even one of them or multiple of them have some problem, rest assured that your user can still sign into your application. So to put this into perspective, we launched 3 years ago, and now we host billions of user accounts for millions of developers. You know, as users, we all love to do things our own way, right? And we want the system to actually work for us instead of against us. That's why Firebase Authentication is built with flexibility in mind. What does that mean? So for a developer, if you are building application from scratch, or maybe you have some legacy system that you're using, but you want to gradually migrate to Firebase Authentication. Or maybe you are very happy with your existing system, but you just want to use Firebase Auth for some other reasons. So all of these are supported. And then from the user's perspective, they can pretty much bring all the credentials that they already have and start to use your application. So the last principle here is extensibility. So in today's software development space, it's very hard to imagine that that all the code that your application needs is running in a single binary. Very likely, you will have different services as building blocks for your application. That's why Firebase Authentication is integrated with other services in Firebase, as well as Google Cloud Platform. So it's easy for you if you need other systems, such as storage or anything. And even if your dependent system is not on Google, it's on, for example, AWS, or it's on somewhere else, that still works, because the token that we issue is actually a standard-based. So you can use open source JSON library that's available out there and easily integrate your system. Another perspective for extensibility is actually application itself. As a platform, we want this solution to be useful for all different types of application. That's why we have this custom attribute. So it's easy for you to put application-specific information into that user's account. And after user sign in, this account will be made available to your application. So that's about the principles. So you may be wondering what has been new since last time we talked. Let's look at that. So we heard it loud and clear that users want more choices. So we introduced more ways for users to sign in. Here, the first is Microsoft. We support consumer as well as organizational account sign-in. And for the gaming community, we added play games and game centers. That means because user is usually signed in their device, this will mean that you can get the user's account information with no friction to the user. And last, we added Yahoo as well. Let's take a look at the code. Here's a little code snippet. In this JavaScript, first thing I did is that I initialize an object that represents a social identity provider, which is Microsoft. Next thing that I did is that we put some extra parameters to tweak the sign-in flow that the user goes through. First, we always ask the user to consent to the permission that we require. And next, for this case, we can get the user's email address from the context of the app. So we just put it in the login hint. This way, the user don't need to type it one more time when they sign in. And then with just one line of code, it will handle the user's sign-in flow from your application to the IDP, and from the IDP to the redirect, and from the redirect back to your application, and with that result of the sign-in captured in the result object, and you can get users' information from there. Of course, sometimes things happen. The user might deny that request, or the IDP might experiencing some temporary issue. In this case, we need to handle the error. Now, back to Marc.
So sometimes when you're building a client-side app and a back-end application, you want to be able to get the user to get access to sort of back-end databases, get access to services that might not be living client-side. And you may have heard of service workers, something that's pretty well supported across browsers these days. And so service workers are really, really important because what it means is that you're able to write code client-side, register a service worker, and then enable that authentication request to just seamlessly, silently pass from your client all the way to your server. You don't need to worry about tokens becoming out of sync, be able to authenticate client-side, then re-authenticate back-end. We see some pretty bad habits if people decide to write client-side code to sign a user in and then back-end server code to try and do the same thing with tokens getting out of sync and things like that. So service workers are really, really important to us. The benefit to you as well from a performance standpoint is you don't need to include Firebase code across all of your applications, all of your pages. So put it on the sign-in page, then let the service worker handle the token refresh, passing the token to and from your front end, your back end, between services. It also, in Bob's case, obviously, we don't have to worry about token refresh as much. We don't have to worry about putting code across pages that might be resistant to upgrading. It also protects them against cross-site request forgery attacks as well, because the service worker is only single origin. So there's a bunch of good stuff here, both for Bob and hopefully for you guys as well. Now, service workers need to be registered on the browser that you're using them in. As I said, most browsers support these pretty well, but depending on your audience, if you're a big old bank and you've got old versions of Internet Explorer or something in your environment, you might be resistant to deploying these. But the first task is to deploy the service worker in the browser, or register the service worker in the browser. The next thing, as Ying just showed you, sign in with any provider. In this case, I'm using Microsoft in order to do a sign-in. And so what we're going to do is we're going to sign in with a pop-up. The user sees a pop-up, signs in with their credential. And then once they do that, we're going to send the browser off to a different page. And in this case, what the service worker is going to do is it's going to grab that token, it's going to pass it back to the back end, and you have to worry about having to put client-side code on the back-end server or anything like that. The token's always fresh, always ready to go. Situations where maybe the service worker's failed to register or there's been problems with it as well, so always catch the error and then behave appropriately as you'd need to.
So you probably have already went into the situation where your application needs to send emails to your user. This can be the user forgot their password and you want them to get back to their account. Or maybe sometimes you want to have a verified email on your account record so that sometimes you can communicate with your user for some other purposes. So Firebase Authentication actually already supports this, but we know that there are more rooms for customization. That's why we launched the email action link. So in a nutshell, what this does is that you can call our APIs and get a link which has a temporary password in it. And then you can embed that link into your email communication to your user. So obviously, this will allow you to maintain the brand and style across different channels of communication. But more importantly, it will allow you to provide more context of that email communication to your user. And when the user have a clear understanding of what is going on, they're more likely to respond to your request. Of course, this also gives you another additional benefit is that this allows you to send the email content with your favorite SMTP server. So to make this work, first thing we do is that we need to initialize an object called action code setting. This allows you to put additional state in that redirect URL and also allows you to provide different identifiers across the platform. And then you have this email address that you want to send an email to. So you call our admin SDK, and then it will return that link we talked about earlier. With that link, you can compose the email that you want, and then send that email to your user. Of course, things happen. We need to handle the error properly.
So if you're a big old bank, you're probably concerned about the safety of your user logins and things like that. As you'd expect at Google, we're pretty cognizant of that as well. There was a session in here yesterday, and they said sort of 99.9% of threats against attacks, Google actually blocks with just single factor. So we filter all of that out for you. What we also offer, though, is this thing called cross-account protection. So what that means is we take Google's signals and give them to you, our developers, so that you can have those signals as well when you use Google Sign-In and other Google properties. So essentially what that's doing is taking Google's threat intelligence network and giving it to you so that you can figure out how to respond when you see risky sign-ins and things like that. And the best thing is this is seamlessly integrated by default. You just have to start listening for it. And so if you recognize that someone's under attack, something bad's happening, we give the power to you then to decide what you want to do. Maybe you want to disable the account, log the user out, force them through some other flow or some custom flow that's critical to your business. So this is really up to you about how you respond to it, but we want to give you the information to make an informed decision. And so what happens here is that if you start listening for these cross-account protection responses, you'll start to see these JSON blobs come to you. I'm going to break this down into 3 parts. The first one here, you can see this is being issued by Google at a specific time. So you know when the threat happened and that you can trust that it was Google that issued it. You can see here we have an event. Here it is, an account disabled. So what this means is that Google has actively disabled the account in our system, just to let you know that, hey, maybe you should do something about it in yours. Here we have a subject which I want to call your attention to. So if you've used Firebase Authentication, you've probably seen an identifier for the Google provider on those user objects, and this lines up here as well. So we try to give you all the information we can so you can make an informed decision about what to do with this account. And finally, we've disabled this account because it's under hijack. So we tell you why we've disabled it. Some threats you may not care as much about, some you may care far more about. The worst thing that could possibly happen is if someone's stolen that credential or stolen that password and they're using it to access your system, then your data's at risk, your users are at risk, and your reputation is at risk. So we give you all of this information to make sure that you're informed. So we've been really, really busy over the last 12 months or so. But let's see if we can help Alice and Sue build WALP. So I want to talk to you now about 3 new ways to secure your application. I'm going to talk to you about preventing account hijacking. We're going to talk about monitoring activity, auditing activity, and then being able to use that telemetry to be able to make informed decisions about how to build your application, how to improve it, or whatever the case may be. And finally, how can we secure and extend, as well as customizing the sign-in and sign-up experiences? So let's get to it. This is what they came back with. Sue and Alice started to build the app, and this is WALP. You can see we've got username and email and password sign in here, as well as sign in with Google and sign in with Microsoft. But we're talking about people's finances here, and so even though you might have the best threat intelligence information in the world, you want to block them at the front door as much as you can if they're a malicious actor or a bad actor. And Bob hasn't lasted 100 years by taking undue risks and not caring for their users. So let's go about adding an additional layer of security. I want to talk to you a little about something new that's coming out in the near future called MultiFactor Authentication with SMS for Firebase Auth. This isn't a new method to authenticate, but really extending the way that Firebase uses credentials. So the first thing you have to do is actually get people enrolled in it. You can see here we've got the start of an enrollment flow. So we use reCAPTCHA to make sure sign-ins aren't abusive or that it's a real user behind the computer, as well as the MFA provider. In this case, we're using the phone factor for SMS. I'm going to start my multi-factor session and pass that off and collect the user's phone number as well as that session information. And then I'm going to package all that up in order to verify the user's phone number to make sure that the number that the user entered is something that they actually own. So they're going to get a text message on their phone that we're going to prompt them to type into their computer. Once they've typed it in, we're basically ask them to give the MFA factor a display name because we allow you to register a number of different factors. And so at a glance, you might want to have a list of 3, 4, whatever the case may be, so that someone can say, you know, this is the one that I registered. Maybe this is my spouse or my partner or my, someone else's. So that then enables us to protect each account at login. So during a login operation, it looks kind of similar to the enrollment. We have to, again, register the providers. And then in this case, what we're doing is signing in with the first factor. So we're signing in with Microsoft.com as we have in the other examples. And what's going to happen here is we're going to throw an error. This user's enrolled in MultiFactor Authentication, and we're going to give that to you in the MultiFactor Auth required message here. So if you see that message, what we then ask you to do is register the resolver object and take that and ask the user to pick the MFA option that they want to use. So we'll present a list of display names through our hints. When the user selects it, they're then prompted to, and so there might be issues, and you should catch them. When the user selects the factor they want to use, we're then going to ask them for a code. They're going to get a text message on the phone. We're going to ask them for that code. And then we're going to complete the sign-in if the code's been verified. Now, if you've used our phone authentication for a little while, the best news here is that you don't need to send text messages or SMS messages when you're testing this out, trying to get it working in your system. It works with our existing phone auth testing methodology, where you sort of just punch in a phone number, register a unique code, and then you can go about testing that without having to send out multiple text messages and doing all sorts of interesting reCAPTCHA things and other bits and pieces. So that's going to allow us safe and secure access to WALP. But now that I've protected my users, people are logging in, they're using it, but I have to debug a problem. I have to be able to audit changes that happen from administrators or someone else in my environment. As a product manager, I care about the success of the application. I care about how are people using it, where are they using it, why are they using it, what devices are they using it on. So stack driver logging and auditing integration is something that we rolled out just recently. This is available to you today to be able to use, so feel free to turn it on and start to make use of it. We've seen massive, massive value for a lot of people already. And so today we do this via a REST call. There's one tip here for the auth token piece. There's a number of ways to get a Google auth token. One simple way, if you're just going about testing, is to use our OAuth playground. Super simple. You get an access token, you can paste it straight in there and make that call. And then you essentially send this to our configuration endpoint and update to enable stack driver. So we're rolling out user interface and things like that in the near future. But I want to be sure that this is available to you today to be able to troubleshoot your problems and look at telemetry and other things like that. So with that, I'm going to get Ying to show us how you put that into WALP.
Let's switch to the demo. So here, the first thing I'm going to show you is how the user opt into multi-factor authentication. So let's say this is the app that Alice and Sue built. Let's say I'm a user, and today I'm going to sign in with my Microsoft account. I would type in my credential, and get my password. So this is how a user without MFA would sign in. So here I'm in the application. And now, as a very security-conscious user, I want to protect my account so that this is my money. I'm cared about them very much. So I'll go here and enroll my SMS here. So I'll type in the number 5612235. And I would expect to receive a code shortly. That is 076. Sorry. 765. And I'll name it so that later I can remember what is this phone number. I'll just say demo. And now I'm enrolled. So how does the login flow looks like? Let me sign out. I'll sign in again with the same user. Because I just signed in with Microsoft, so I don't need to type the credential again. So here is actually the part where Marc just mentioned. The application will receive an error, and to handle that error, we prompt the user with the multi-factor that they already enrolled. And let's go ahead. This looks good. And I expect to get another code, and here I get it. It's 062370. Sorry, 370. And now I'm signed into the app. So that is from the user flow. But on the application side, what you will get is a token which specifies the user actually signed in with second factor. If the user wants to do some sensitive information, and let's say that you see that they don't have the second factor, and you might want to send them back to the enrollment flow so that their account is securely protected. So that is about multi-factor authentication. Next, I'm going to show you how Stackdriver login works. So Stackdriver login, there are two parts. One part is, for example, if you have a team of people, not just yourself, working on the application. And then there's a bunch of configuration that people can do in that configuration. And if someone changed something and you want to know what is going on, this part is called the data access log. So you can turn this on by going to Cloud Console and go to the IAM page, and there's Audit Logging tab here. If you select that and you turn on the admin read, data write for your Identity Toolkit API, which is the backend API for Firebase Authentication. After you turn that on, you will start to see logs in the Stackdriver. So again, in Google Cloud Console, you go to Stackdriver login section. And here, I selected Identity Toolkit project. And then the log that I want to see is about data access. So who changed what? Obviously, there's no activity last hour. Let's see what happened during the past day. So we can see that this user actually went in and looked up a bunch of things and then updated some stuff. Like, for example, here, update configuration. Then you can drill into the details and see what they updated. That is the part where data access is about. And there's also another part where it's relatively harder to to find out is what is happening on the user side. Because you have an application either running on the user's device or running on the browser. For those kind of logs, you need to enable it by sending the request that Marc just showed. And what happens is that once you turn that on, we can start to see which user is interacting with which endpoint of the service. So what's interesting about this is that you can see here the user sign in with, for example, Microsoft. They will call sign in with IDP, or the user's application. If you want to get users' account information, you will call get account info, et cetera, et cetera. And then with this raw data, it might be not too much informative from time to time. So in this case, you can create some metrics that can give you insight as how your user interact with your application. For example, you may want to know, am my user using my app on Android, or are they using iOS, or are they using on web, et cetera. So here I created one metrics which just calculate how users sign in through identity providers. So if we look at this, we can actually see different identity providers popping up here. Take a little time. Let's see, for example, 6 hours of data. So here we can see some users sign in through Google, and some users sign in through Microsoft. And here, there are some cases when the identity provider has some problem, then it doesn't show anything. But we know that some error happened here. Another useful feature for Stackdriver is that you have control over what you want to log. For example, over time, you can see a lot of logs coming to Stackdriver. and you think, oh, it's not very important, or I just want to focus on some specific part of the logs. So here you can set some exclusion filters, and just so that only the thing that you're interested in are logged. Everything else it will be ignored, so that you can focus on that. So that's stack-driven logging. Now let's back to Marc.
So I'm going to save the best to last, and I'm going to be quick because I want to show the demo. Warp's not ready for the public yet, so we want to be able to, if you've tried to log into Warp from your seats there, you might have seen that, hey, I can't log in, and that's as intended. So we're pretty excited about this functionality. And what we want to do is be able to extend the sign-in and sign-up experience so that we can enable you to do whatever you want. And so today we're announcing blocking or synchronous functions, and this will be available in the near future as well. So what we're offering is before create and before sign-in. And I want to be really crisp with what these mean. We've offered sort of functions integrations for a while, so you can throw sort of, send the user an email when they sign in or sign up for the first time, or when they delete, you can clear out all their data in your backend. In this case, we're actually going to stop the user from being created until the function returns with some response. And during sign in, we're going to do the same thing. So the user tries to sign in, we call out to this function. The world's your oyster at that point, and you can do whatever you need to do with that user. So pretty exciting. This is a sample function that Ying's about to show to you, and essentially we're checking Firestore for authorized emails. If we can find the authorized email, if we can find that the user that's trying to sign up is actually allowed to sign up, what we're going to do is we're going to put a custom claim in that token before we return it to the end user. If that user's not found, what you may have seen is that you will see a logon page where, hey, this user's not authorized to sign up for this service or sign into this service. And you might render that beautifully on your page. In our case, we're going to give it to you raw. So I'll give it back to Ying to show us how that works.
So let's take a look. We already deployed a function. Let's quickly take a look. So it's pretty much what Marc just showed, except we added some logging. And then in Firestore, we already set up a collection which lists all the allowed users that can access this application. Meaning that if a user tries to sign in this application, but they are not in this list, then the user will be blocked. Now, let's back to the application. This time, I'm going to sign in with my Google credential. I'm a curious testing user. So I'm going to try this application. Now it said, OK, this user is not allowed. It's not authenticated. That's Firebase. This is a blocking function.
Awesome.
Back to Marc.
So just to quickly recap, we're extending this and investing this more than we ever have before, and Firebase Auth is ready for you. So whether you're building a weekend project, something to keep you entertained overnight, or you're building your Bob and you're building the next world's class banking application, Firebase Auth is the right place to come. We're flexible. Bring your own users, bring your own providers, or use our system to store your users and do things like that. We're endlessly extensible, so we use open standards, as Ying was talking about, and security first. We put security ahead of all others. This is what knowing about identities is primarily about. And we continue to invest in this every day, so offering more flexibility, easy to use, and more secure are things that are really important to us. And as you saw in the blocking function example, how can we extend this to do whatever you need to do with the authentication system that you choose? So that was 3 new ways to secure your application. SMS-based MFA and blocking functions will be available in the near future. If you're interested in getting involved, I certainly encourage you to hit the Firebase Alpha link that's listed there below. And Stackdrive is available today, so you can find that documentation online, either in our Cloud Docs or in our, there's some Stack Overflow stuff there as well. So if you have any questions, we're going to race after this to Tent F, the Cloud Firebase Dome. Please come past, have a chat. Happy to talk more. Thanks for coming.